So for the past quarter, I've been researching the formation of snow penitentes, which are basically just giant ice spikes that form on the surface of extremely cool, dry, and sunlit glaciers. For many years, it was believed that they form as a result of erosion by strong winds, but in recent decades, it has been shown that they form as a result of solar melting of snow. So basically, some regions of the glacial surface are being hit by more light than other regions, causing them to melt faster. When first examining a small deformation on the snow surface, it appears that light is hitting every point on the surface evenly. But as it turns out, reflection plays a huge role in this process. In order to understand why reflection is the driving force behind this process, we need to look at how light is reflected at several points along the surface. Shown in blue and described by d theta is the range of angles across which light is scattered from the lowest point of the depression. The green portions along the curve show the locations which are hit by this reflected light. So the light reflected from this point is hitting the bottom and sides of the curve, but not the peaks. Moving to a location slightly further up the curve, we have a similar situation. The incoming light is scattered across the curve and hits the opposite side. Again, the reflected light hits the side of the curve and leaves the peak unaffected. Moving further up the curve, we see the same pattern play out. However, when we reach the peak of the curve, we see something very different. Instead of being reflected to another point on the snow surface, all the light is scattered into space. This pattern also takes place on the other side of the curve as well. From this, we see that much more light is striking the sides and bottom of the curve than is striking the peaks. Because of this, the troughs melt at a much greater rate than the peaks, causing penitentes to form. Although it may not seem like it, this is a relatively simple mathematical model for the growth of penitentes in time. H is simply the height of the snow above some predetermined reference point, which makes dh dt the change in this height over time. P of x is the power per unit horizontal area, which is simply describing how much light is hitting a given point on the surface. L is the latent heat required to ablate a unit volume of snow. This is simply the amount of heat it takes to turn water from a solid into a gas. D is simply a diffusive constant, which describes how far down light goes into the medium. This is multiplied by the second derivative of height with respect to x. This describes how quickly the height is changing in the horizontal direction. This quarter I developed an apparatus which can be used to create penitentes on a smaller scale in a lab. The main body is an insulated cooler in which an ice block rests. The main body of the cooler is kept at a temperature of around -20 degrees Celsius. This is done by running dry compressed air through a container filled with liquid nitrogen.